division. And I'm going to ask myself, x times what gives me x squared, and what do I get? 1x. And then I multiply down. I subtract. These are the same steps in regular long division. What do I have to be careful about on this step? Make sure you subtract both pieces. And subtracting a negative 2 is like adding 2. So I get negative 4x plus 9. X times what gives me negative 4x? And negative 4 times x minus 2 is negative 4x plus 8. I subtract both pieces. I get 0 and 1. And so the answer is x minus 4, remainder 1. We're going to learn a shortcut to polynomial long division today, and it's called synthetic division. How many of you remember synthetic division from Algebra 2? Okay, so we're going to learn synthetic division. Synthetic division is wonderful, but it has its hang-ups. One of them is if the denominator is anything besides x plus or minus a number, whoops. If it's anything besides that, then I can't use it at all. So, is this a complete replacement for long division? No, but if the divisor is x minus something or x plus something, then it's a really good shortcut. The other hang up to it is that in polynomial long division, if we forgot a placeholder, as long as we were really careful, it was okay. You know what I'm talking about. As long as you didn't add in unlike terms together, you were fine. With synthetic division, we're going to shortcut so much that if you forget a placeholder, it will mess you up and you won't be able to get the correct answer. So what we're going to do, the creator of synthetic division said, I always forget to change my signs, right? So the first thing they did is they changed the sign of the divisor, the x minus 2. They changed it to a positive 2. They put it in a little box. And then they took the coefficients of the polynomial. Well, what's the coefficient, the first coefficient of the x squared? 1. What's the second one? And the third one? And then they just pretty much started taking shortcuts. But it led to synthetic division, which is a nice shortcut. So the first thing we do is whatever number this goes into, whatever number is in front here, won't that be the coefficient of this answer? So the first thing they did is they just brought down the number and said that'll be the coefficient of my answer. If I am truly dividing by x, and only x, won't the answer always be 1 power less than the divisor? Because you just divided 1x out of it. So if it's a cube, you'll go down to a square. If it's a square, you'll go down to an x. Then you multiply the 2 times the 1 and you put it here. So you multiply and put that answer here. And then your step is to always add down. So I added 1 down, multiplied, put it here. Add down. What's negative 6 plus 2? So add down, multiply. Negative 2 times negative 4 is negative 8. Add down. The last number I'm going to put in a box because it is the remainder. These are the coefficients of your answer, the quotient. No, I did 2 times 1 and I put it here. Now, I start by adding down first. So you add down first, then multiply, then add down, then multiply, then add down. The degree is 1 less than the degree that you started with because we divided out an x. So this is the coefficient x minus 4 remainder 1. Do you see how it does all of these steps just without as much on paper? Now that was the first one. We'll do a few more so you get the pattern. That's kind of the why it works. Okay, so now I want to divide 3x cubed minus 2x squared plus 3x minus 4 by x minus 3. And now I want to use synthetic division. And it tells me how to write the answer, and I'll show you what that means. So the first thing I'm going to do is put something in a box. What goes in the box? Positive 3. And remember, whoever came up with synthetic division was making us not have to do a bunch of subtraction by changing that sign. And I'm going to put the coefficients. 3, negative 2, 3, negative 4. I do want to mental note. You see this 3, 2, 1, none? What if one of them was missing? You have to put a 0 in. You cannot skip that step. It will make you get it wrong. I'm going to add down. Step 1, add and then multiply. Add and then multiply. Add and then multiply. Miss something?
That's one thing, but I know what to do. I just did it. It's why I did it. I'm going to put y instead of 7. So
I'll just take it real quick. Oh, you're going fast. One more time. Okay, add down. Everyone agree? Multiply. Am I going too fast? You always start by adding down. Always your first step is to add down. Then multiply. Then add down. Then multiply. Is this faster than long division? And I'm going slow through it. I'm going really slow. It's still really fast. So I don't have as much thought into it. So it's a great shortcut. It is not a replacement, but it's a great shortcut. 3 times 24 is, what, 72? And then add down. My last one goes in a box. So let me say all of this one more time. You add down, you multiply, you add down, you multiply, you add down, multiply, and add down. Everyone see how we're getting those numbers? The first one looked a little scary, looked a little hard, but as we start doing this, it's the same steps. Now, it tells me to write the answer in this format, and I'll show you what that means. First of all, the quotient, Q of x. The quotient is the answer. That's the 3, and what would the exponent be beside the 3? Y squared. It's always 1 less than what I started with. I start with a cube, it drops down 1 power. Plus 7x plus 24. Now, normally I write remainder 68, but it told me to write this little term here. The remainder is 68. The d of x is the divisor, and that's the x minus 3. Now, what we're doing there is we're saying if we truly divide this, we get this plus 68x over 3. That's what's left over. Just like if you were to divide 10 by 3, you would get 9 and a third. Does that make sense? Or 10, you would get 3 and a third.
You know, try it like that and just synthetic, or just whenever it asks that?
Only when it tells you to. Yeah, only if it says to. The next question is an interesting question. It asks us if x minus 3 is a factor, yes. Right here. It's always opposite sign of this. So you just change the sign. It asks, is x minus 3 a factor of that polynomial we just divided it out of? If it were a factor, so let's try something that's a factor. So what's a factor of 10? Someone give me one of the factors of 10. 5. What happens if you divide 10 by 5? You get 2. Remainder what? 0. If something is a factor, do you agree there's no remainder? There is a remainder. So is it a factor?
No.
No. And for note purposes, bring me the key. This part you don't have to write normally, but this is just for your notes. This is not technically x equals, I'm going to give it to you. It's not x equals, it's f of g of 2 equals that. You're welcome. Yes, please. Thank you. Because the remainder wasn't 0. Up here. This is this problem. It's the same problem. Yes. Good question. If it were a different problem, I'd need to do the synthetic division. But if the remainder is 0, then it's not a factor. If the remainder is not 0, then sorry, did I say that one? If the remainder is 0, it is a factor. If the remainder is not 0, it's not a factor. This one, and again, think about regular numbers. 10, if I divide that by 5 and 2, I get no remainder either way because those are factors. Okay, let's look at the next one. It says factor the polynomial given a factor. Well, to do that, first I need to divide that factor out. So I'm going to put 6 in the box. Why 6? The x minus 6 is what I'm dividing out. It's telling me x minus 6 is a factor. Since it's telling me that, what should my remainder be? I better get 0. If I don't, what does that mean? I did something wrong. Because it said it was a factor. Or it's a bad problem, one of the two. Add down. Multiply. Add down. Multiply. Let's see, that is 18... 78, yep. And that's 40. 240. Is it a factor?
Sure.
It is. What that means is that I could have rewritten this polynomial as x minus 6 times x squared. Where did I get the x squared, by the way? One power down. X squared plus 13x plus 40. Could I have ever factored a cubic like that before? No. So I just factored something that I couldn't have factored before. And I'm going to factor that some more if I can. What are the factors of 40 that add to give me 13? 8 and 5. So I completely factored that polynomial just by them giving me one of the factors. Does that make sense? Any questions? notes. It's your call. Here's the homework. Notes are,
We're
you-
just starting.
yes. So I don't know. You can make that judgment. We do grab one of these and pass them around. Okay, I am going to go ahead and give you your homework. Try to do it before Monday. Most of it you can do. I am going to do it the same thing I did last time, kind of give you a leeway day. We are still probably going to get new homework on Monday, but if you have, since we're kind of rushing toward the end here, if you aren't, we'll finish the notes up on Monday, so it's not actually due. But if you wait until Monday to do the homework, you'll have double homework. So be careful. Okay. To factor this polynomial, it says k equals -3 is a 0. I have a question. If -3 is a 0, what was a factor? X plus 3. And since there's a multiplicity of 2, would you agree x plus 3 was a factor twice? Okay. What goes in the box? -3 goes in the box. Why -3? Opposite sign of the factor. Now, they gave us a 0, so a lot of people will mess this one up because they'll try to change the sign. Does everyone see why I don't change the sign? I do, because I changed the sign of the factor. 1, 6, 1, -48, and every time I'm checking, and we haven't done an example, so be careful on your homework, because I think the first example is like, or the second one somewhere, is like x cubed minus a number. What has to go in between if I skip all the way from x cubed to a number? Has to be a 0 for the x squared and a 0 for the x. So I'm going to add down, multiply, add down. Did everyone get a worksheet? If not, they're back there by Nate. They're on the desk back there by Nate. Number 1. We'll finish on Monday, but try to do as many as you can tonight.